Hello everyone, this is Abdurrahman Jawadi, and today I'm going to be presenting my presentation about the trends of the periodic table. I'll be discussing 5 trends of the periodic table. The first is ionization energy, the second is the atomic radius, the third is the ionic radius, the fourth is the electron affinity, and the fifth is electronegativity. I'll also be discussing effective nuclear charge, electron shielding, and Coulomb's law, and how they relate to these trends. First off, I'll start by explaining the effective nuclear charge. Effective nuclear charge is the net positive charge experienced by an electron in a multi-electron atom. The formula for effective nuclear charge is as shown. Zf represents effective nuclear charge. Z represents the number of protons in the nucleus, and S represents the number of inner shell electrons, also called the shielding constant. So Z minus S will be the formula to find effective nuclear charge. And there's a diagram to explain effective nuclear charge as well. Next I'll be talking about electron shielding. Electron shielding is the blocking of valence shell electron attraction to the nucleus because of the presence of inner shell electrons. So the inner shell electrons decrease the attraction between the valence electron and the nucleus because of the shells, and that is called electron shielding. Next I'll be talking about Coulomb's law. Coulomb's law is the force of attraction or repulsion acting along a straight line between two electric charges is directly proportional to the product of the charges and inversely to the squared distance between them. The formula for Coulomb's law is as shown. F represents the electric force, K represents Coulomb's constant, and Q1 and Q2 represent the charges, and R represents the distance of separation. So when the charges increase, the force needed will also increase, and when the distance of separation increases, the force will decrease. The first trend of the periodic table that I'm going to be talking about is ionization energy. Ionization energy is the minimum energy required to remove an electron from the ground state of an isolated gaseous atom or ion. The figure below shows the ionization energy trend. When going from left to right across a period, the ionization energy increases, and when going down a column, the ionization energy decreases. Now, what is the relation between ionization energy and effective nuclear charge? Going from left to right will have more protons, which means that the effective nuclear charge will increase. And going from up to down will have more electron shells occupied, which will mean that effective nuclear charge will decrease because there will be more inner shell electrons. Now, what is the relation between ionization energy and electron shielding? When there is more electron shells available going up to down, the ionization energy will decrease because there will be more inner shell electrons. Now from left to right, it changes depending on the atom's number of electron shells. And then the relation between ionization energy and Coulomb's law is that elements going from left to right will have a stronger bond because the charges will be more. And the elements going from up to down will have a weaker bond because the distance between protons and electrons is further. And as we know from the formula of Coulomb's law, that this will decrease the amount of energy and the attraction. Next trend I'm going to be talking about is the atomic radius. Atomic radius is the distance between the nucleus of an atom and the outermost shell of the atom. We can see the trend shown in this diagram. Atomic radius decreases as we go across a period from left to right, and increases as we go down a column from up to down. Now, what's the relation between atomic radius and effective nuclear energy? The number of protons increasing decreases the size of the atom. So, with higher effective nuclear charge comes less atomic radius. And the relation between atomic radius and electron shielding is that when there are more electron shields, the atomic radius will increase. And the relation between atomic radius and Coulomb's law is that when the charges of an atom increase, the attraction between them increases too, meaning that they will try to come close together, therefore having less size and less atomic radius. and having many electron shells increases the distance of between the nucleus, which will make the electron atom bigger. The next trend I'm going to be talking about is ionic radius. Ionic radius is the distance between the nucleus of an ion and the outermost shell of the ion. As shown in the figure below, the ionic radius for cations decreases going across a period. And the same happens with anions, but their size will be smaller than those of cations. And the ionic radius increases as we go down a column, from up to down. Now, what's the relation of ionic radius to effective nuclear charge? When the ionic radius is larger, effective nuclear charge is less because there are more inner shell electrons, meaning the effective nuclear charge will decrease. And the relation between ionic radius and electron shielding is that when the ionic radius is bigger, electron shielding increases because there will be more electron shells in the atom. And the relation of ionic radius to Coulomb's law is that when the radius is bigger, the distance between the nucleus and the electrons increases, meaning that the attraction is weaker. And when the ionic radius is smaller, there are more charges, which makes the attraction stronger. Next trend I'm going to be talking about is electron affinity. Electron affinity is the energy change that occurs when an electron is added to a gaseous atom, and that is called electron affinity, because it measures the attraction or affinity of the atom for the added electron. As shown in the figure below, electron affinity increases going from left to right across the periodic table, and it increases going from down to up of columns. What is the relation between electron affinity and effective nuclear charge? When the electron affinity increases, the effective nuclear charge increases as well, because there will be more protons. The relation between electron affinity and electron shielding is that when electron affinity decreases, the electron shielding increases because there will be more electron shells. And the relation of electron affinity and Coulomb's law is that when the electron affinity increases, the strength of the attraction between the electrons and the nucleus increases because there will be less electron shells and more charges. The next trend I'm going to be talking about is electronegativity. Electronegativity is the tendency of an atom participating in a covalent bond to attract the bonding electron. Shown in the figure, electron negativity increases going across a period from left to right and decreases going down a column from up to down. Now, what is the relation between electronegativity and effective nuclear charge? When electronegativity increases, effective nuclear charge increases too, because there will be less inner shells. Now, when the electronegativity decreases, the shielding effect increases because more electron shells would be present, which will make the shielding effect increase. And its relation to Coulomb's law is that when electronegativity increases, the strength of the attraction between the electron and the nucleus increases, because there would be more charges. And when electronegativity decreases, the strength of the attraction between the electron and the nucleus would also decrease, because more electron shells would lead to a greater distance between the electrons and the nucleus. Thank you for watching this presentation. I hope you enjoyed. These are the sources I used to help me for this presentation. Thank you.